If you've ever taken a high school physics or chemistry class, you've probably heard the phrase, matter cannot be created or destroyed. This principle is called the conservation of mass, and it means that in a closed system, the initial total mass will be the same as the final total mass, or the mass at any point for that matter. We can express this mathematically by saying the initial mass is equal to the final mass. So as long as you do not add anything or take anything away, the mass will stay the same. Makes sense, right? But I'm going to give you an example where that is not necessarily true. Let's take two particles. One of them is an electron and the other is a positron. What you need to know about these particles is that they both have mass. So our initial mass is greater than 0. The next thing you need to know is that electrons and positrons are what is called a particle-antiparticle pair. This means that when they collide, both are destroyed. In the case of electrons and positrons, no mass is left behind. So if our initial mass has to be equal to our final mass, what happened to the mass of those two particles? Believe it or not, you probably already know. E equals mc squared describes the mass-energy equivalence. What it tells you is that the energy of an object at rest is equivalent to the object's mass times the speed of light squared. A slightly more complicated equation is needed for moving objects, but this equation shows us the concept. We also find that with this equation, mass is just a form of energy. So particles with mass can become massless, highly energetic particles. Going back to our collision, we find that the mass of our two particles becomes energy carried by two photons, also known as the particle of light. They have no mass, but plenty of energy, enough that it satisfies E equals mc squared. Einstein's theory shows that the opposite is true as well. You can create particles with mass from massless particles like these photons, although the process is a little more complicated. So then matter can be created and destroyed? Well, remember, mass is just a form of energy, so really all we're seeing in this experiment is energy changing forms from the mass of those particles to the energy of the photon.